Hi, welcome to clickmyprojects.com. Let we discuss about the title is a hierarchical approach for the resource management of very large cloud platforms. The main objective of this title is to optimize and manage the resources utilized during the process between server and client. It is processed in a step-by-step process. It is called as a hierarchical approach. Let we discuss about the abstract of the title. Nowadays there is an enormous increasing of cloud computing. So during the service provided by the providers to the client, there is a lot of energy or resources can be lost. So the biggest problem in the cloud computing is to manage the resource management when providing the continuous service and performance guarantees. So the main objective of this paper is to plan the resource allocation policies for virtualized cloud environments. It is a scalable distributed hierarchical framework. It is based on the mixed integer and non-linear optimization technique of resource management. It must satisfy the performance and guarantees and must minimize energy costs in very large cloud service providers. The main objective is to maximize the profit and optimize the resources utilized during the process. It is represented in a hierarchical format. It is based on some timing scales like T1, T2, T3, etc. Through this approach, it maximizes the cost, improve the efficiency and then effectiveness. Let me discuss about the DFT of the title. Hierarchies has been classified into two hierarchies. They are central manager and then application manager. First up is the central manager process. It is a process of classes and servers partitioning. That means clients and servers are partitioned. In this, we calculate the time scale called as T1. Next step is application manager process. It has been classified into two problems called as long-term problem and then medium-term problem. Medium-term problem is about server switching process, that is posting the heavy load servers into sleep state and into active state. It is also called as a load balancing. In this, we have to calculate the time scale called as a T2. Then we can estimate the frequency and resource utilizations of each and every process. Each and every process can be posted into a free server pool. Running the client and server for a very process and evaluate the resource utilization and frequency for every process within time scales and display the graph. Let me discuss about the coding sessions of the project. Now I am going to run the title page of the design. Just we have to I give the title of the project, and if I click the submit button, it sends to client class request page. Okay, then we have to get the IP address of the system, and then click the client one. Means if you are a client, means you can be allowed to send the data to the virtual machine. Then how to choose the file chooser. I am going to send a file to a server, that is a process. We have to choose the file. That means to choose the locations like just as my colon my project, then my project to one. Then we to choose the text file, any one text file. And then click send file to VM1. Okay, then client transfers that file to the server. Then we have to run the server file. That means we have to click the virtual machine file, then run the file, get IP address of the system, and then get the desired file to transfer. That is decoder, and then my project, and then my project one. Then I1 text. We have to click to choose the desired file. File 1, then open, then get desired file. Okay, sorry, then accept the file. Then server gets a request from the server gets accept from the client. Then to display the clients partitioning means then display the client process. Get T1. T1 means get T1s in milliseconds, and then 41 seconds, and T1 for calculating the frequency. Get T1, get frequency, and then get resource utilization. It has been sent to for calculating the average response time. Get frequency, get execution time, and then get capacity, and then average response time. And it has been calculated for graph, average response time, and execution time. If the execution time is 41, it displays a graph, and then get the frequency. When click the display chart for server, it displays a chart for the process. Then we have to select the client to process, client second process. That means client's partitioning. Then click the client to, it posts a request, client sends some advice to the server. After client sends a advice to the console, then run the server file, get request 1, then get time, and then send time, and then calculate the T2. It is a normal, it is an active state. Then get resource utilization, and then post time for calculating the average response time. Then get T2, then get frequency, then capacity utilizations of the server 2, then get average response time of server 2, and then post for calculating the graph, get server switching time and execution time. It displays a graph, and then get frequency. It's all about client to process. Then we are going to run about the client 3 process. That means it gives a post request to the server, then server accepts the client's request, accept request, then get REPC server to switch over the process to server, then okay, then get resource utilization, and get time, then post RST, then get T3, and get frequency, and then get capacity, then get average response time, then post ASR for drawing the graph, get execution time, get average response time, then get frequency. Then display the graph for the last process. So these are the process for client 1, client 2, client 3 for service. That is client 1 provides some services, and then client 2 provides some services, and client 3 provides some services. So the server accepts services and responds to that client, and then calculate resource utilizations, and then average response time, and then time for every process. There is a process. Through this graph we can optimize the resource utilizations. That's all.